The global transportation grid is the most heavily capitalized asset class on Earth, encompassing millions of miles of interstate highways, port staging terminals, and distribution corridors that physically move trillions of dollars in real-world freight. However, in 2026, the institutional funds underwriting this multi-trillion-dollar network are confronting a rigid physical limitation governed not by macroeconomics, but by the complex laws of kinetic rheology and viscoelastic fluid dynamics. Modern heavy-use pavements are not static solids. They are highly volatile, temperature-dependent viscoelastic liquids that continuously deform under the immense mechanical shear strain of multi-ton cargo fleets. As global thermal gradients fluctuate, the molecular bonds holding this foundational infrastructure together are breaking down, forcing elite asset management firms to deploy advanced material science to fundamentally reprice the value of global land-based logistics corridors. The foundational science of this structural asset valuation relies on understanding the microscopic behavior of bituminous binders and polymer-modified asphalt matrices. At a molecular level, asphalt is a dense mixture of complex hydrocarbons, polar asphaltenes, and maltine fluids that behave as a non-Newtonian fluid under mechanical loading. When a heavy freight truck passes over a highway, the pavement experiences a rapid cycle of compressive and shear stresses. If the ambient temperature is too high, the bituminous matrix loses its elasticity, causing the molecules to slide permanently past one another, a structural failure mode known as rutting. Conversely, if the temperature drops below a critical threshold, the material transitions into a brittle glass state, leading to immediate microfracturing under mechanical loads. To prevent this, structural engineers utilize kinetic rheology to design proprietary polymers that cross-link with the underlying hydrocarbons, artificially shifting the material's phase angle to ensure it maintains perfect viscoelastic equilibrium across extreme thermal bands. The direct financial utility of this molecular engineering is the implementation of predictive, physics-based asset depreciation models for infrastructure bonds. Traditional municipal and federal bond markets have historically calculated highway depreciation using arbitrary chronological timelines, frequently leading to catastrophic mispricing of risk. By utilizing dynamic shear rheometer (DSR) protocols on core samples taken directly from major freight corridors, institutional investors can now measure the precise complex shear modulus and phase angle of the pavement. This molecular data allows analysts to mathematically calculate the exact number of heavy axle loads a specific highway can sustain before experiencing catastrophic structural binder fatigue, enabling sovereign wealth funds to short sell or acquire infrastructure debt based on hard, empirical physics rather than speculative civil projections. However, executing this level of non-destructive material auditing across thousands of miles of transcontinental highways introduces immense mechanical and computational engineering constraints. Institutional funds cannot afford to manually core every mile of asphalt without disrupting the very supply chains that generate their yields. In response, infrastructure engineers are deploying high-speed laser road deflectometers mounted to autonomous scanning vehicles. These systems fire high-frequency violet lasers at the pavement while traveling at highway speeds, measuring the sub-millimeter kinetic deflection of the surface under the vehicle's own known axle weight. By passing this real-time deflection data through advanced rheological algorithms, physicists can back-calculate the structural integrity of the underlying bituminous layers without scratching the surface, flagging hidden molecular fatigue before visual cracks appear. This convergence of kinetic rheology and infrastructure asset management represents a permanent shift in how sovereign wealth is calculated and preserved. Capital is abandoning historical ledger accounting and anchoring its valuations directly to the physical durability of molecular bonds. The institutional syndicates currently financing the development of advanced polymer-modified binders and automated rheological scanning fleets are establishing an unassailable data monopoly over the physical arterial corridors of global commerce. The long-term survival of logistical empires now depends entirely on mastering the thermodynamic phase changes of industrial materials, proving that the ultimate arbiter of economic continuity is an absolute command over the structural mechanics of the physical matrix.